Hello and welcome to my video, lesson 5.4 on domain and range. So we're going to just talk about some of the concepts and then we're going to take a look at how we would write domain and range in a few different examples. So domain is the independent variables, always the x values, and range is always the dependent variables, always the y values. Okay, so again, look back at some of our previous videos to talk about what those independent and dependent really mean in a different word problem or whatever, but basically, independent is manipulated. If we think about science words, so manipulated variables are independent variables, and dependent variables are like responding variables in science. So there are a couple different symbols that we use here. We've got greater than or equal to, less than or equal to, and then such that, and then this special E, which is like a C with a line in the middle, is an element of, so E for element, okay? The set of real numbers, so it's an R, but you can't really type it very well on a computer, but it is a special R. Okay, and how I do this to make sure that I've made it very clear what I'm talking about is I put a double line at the beginning of the R. So I start with a line, start with another line, and then I just go and make an R from there. So that's how you make that special R. Okay, we can talk about the restrictions on the variable or list the set of variables that is allowed. So yeah, that's how we talk about it. Interval notation is important as well. Becomes more important with, actually only important with continuous data. And the difference between continuous and discrete was in the last video, I believe it was, where we talk about discrete data being like counting data and continuous being things that can be broken up forever. We went through a couple examples of that. Okay, so square brackets will show that we have an or equal to part, or equal to. Round brackets show that there is no or equal to. Okay, so it's just a greater than or just less than. Okay, so domain and range of discrete data. If we have data from a table of values, what we would do if it's discrete is we would just write domain is, and then we'd say tickets. Then we'd actually go like this. Then we write this squiggle bracket to start, T for tickets, such that, oh, actually, no, better yet, because this is discrete, we just go like this. T is contained within just these numbers, 3, 4, and 5. Because those are the only values given to us in the situation. So that's kind of where we stop. Range with discrete data is going to be very similar. So it'll be C for cost with the squiggle bracket 450, comma 600, comma 750, and then the squiggle bracket afterwards. All right, taking a look at this second set of discrete data, I would recommend you try writing this out yourself. Pause the video now and try it yourself. Okay, basically same sort of thing. Domain is always our x variables. So it's going to be our cups sold. Whoops, cups. Okay. Whereas our profit is always going to be our y variables. So that's going to be our p. And let's just do C for cups. And then we'll use the squiggle bracket, and then we go 1, 2, 3, 4, and actually that's where it stops in this question. To look at the profit, we go 0.5, 1, 1.5, and 2, and that's it. Okay, so to continue on with this topic with continuous data, we use a closed circle like that to determine or equal to, and we use an open circle if it does not include that point. So if it's closed, it includes the point. If it is open, it does not include the point. So I'm going to do example 1, 2, and 3, and then I highly recommend you try examples 4, 5, and 6. If you guys can do 1, 2, and 3, pause the video certainly and try it yourself. Okay, so for set notation, we're going to write domain is x such that, and then we write this in between notation. So it's x's smallest value is -3, and then that's less than x, which is less than or equal to 2, with x being a subset of the real numbers. Okay, so that is set notation. You have to write it all very much like that. The rest of it kind of actually stays the same, but this part inside here is the part that changes for every question. Okay, the rest of it actually will stay exactly the same, but this part inside will change depending on the question. So let's see that in action for the y's, for the range. Okay, so now we look at the smallest y value possible, which is -3 as well, but it is or equal to, because that's the solid circle, and it goes till y, and then y goes all the way to 3, and it does not include 3, and then we go y is in the real numbers. Okay, for interval notation, what we would do is we'd say that the domain is round bracket -3 comma 2 square bracket, because the round bracket shows that we have less than but not equal to, and the square bracket shows that it is equal to. Okay, and then for the range, it's the other way around, where we have the square bracket to start, -3 comma 3 with the round bracket to end. Again, square bracket shows the or equal to, round bracket does not. Okay, now let's take a look at this one. You can kind of tell that the x actually goes on forever to the right and on forever to the left. So actually, in this case, the domain is x such that x is not bounded by anything, it's just any real number. So we write it like this. However, the range is bounded. Okay, so what we're going to write is y such that -3 is less than or equal to y, which is less than or equal to +3. Okay, this is a sine curve, and it'd be better if I showed more of it, but whatever. Comma, and then y is a set of real numbers. And you can kind of imagine that the curve would keep going back and forth like that. It would go up and down forever, right? And so it would never move past that. Okay, so if we write that in interval notation, we would say that the domain is, and then we go like this, -infinity to +infinity. And whenever we use infinity, we always will put the round brackets. But notice we used infinity in interval notation, but not in the set notation. Okay, now looking at the range, you can see that they're both or equal to, so we use square brackets on both sides, the max and the minimum. And then example 3, we now go to the domain again, and the range again. Okay, now for the domain, there is a boundary. It's x such that, and then we just write x is less than or equal to 2. X is in the real numbers. So notice there's only one boundary on x, and it's this side. It doesn't go any further to the right, but it does keep going to the left. Okay, and then in the range, it's the same sort of thing. but we say y is greater than or equal to negative 2, where y is an element of the real numbers. Okay, now we're going to do domain and range in interval notation. Okay, domain is going to be written as negative infinity going to 2. 2 is or equal to infinity never is. Okay, in the range, it'll be negative 2 going to positive infinity, and that's the round bracket. All right, so I always recommend you pause the video and try it yourself. All right, so now I'm going to go through and do these examples as well. So the domain for this one is going to be in between notation because there's a boundary on both sides. So this is going to be x such that, and then we have the smallest value of x is negative 4, the biggest value, whoops, and then it gets bigger and bigger and bigger, so it's greater than or equal to x, or less than or equal to x, which is less than or equal to positive 4, not or equal to, sorry, just less than positive 4. And then we put the comma, we put x is an element of the real numbers. With the range, we now will do this again, but for the y direction. And so we have the smallest y is negative 3, and then the biggest y is 4. Actually, I just made a mistake earlier. That should have been a 3 for the x's. And yeah, that's correct now. Had that wrong before. There you go. And so now we do that as an element of the real numbers. Okay, and then interval notation is going to be written like this. So negative 4, 3, round bracket. This will be negative 3 square bracket there, and 4 with the round bracket. All right, so we have the domain is going to be like this. So for this question, you can see that x such that, y such that. You can see that the y will forever increase bigger and bigger after the negative 1. So we say y is greater than or equal to negative 1, with y as an element of the real numbers. But you can notice that the x values will actually continue going to the left forever here and continue going to the right forever here. So we just say x is an element of the real numbers. So if we write this in interval notation, we write negative infinity to positive infinity with round brackets. And for the range, we write that x is negative, or y is negative 1, the square brackets going to positive infinity with round brackets. And then our final example will be domain, range, domain, range. Okay, where x is going to be bounded such that it is between negative 4 and 3. X is in the real numbers. Y is going to be such that it's between negative 4 and 3 as well. Y is in the real numbers. And now for interval notation, we use the round brackets for the negative 4 and the square brackets for the positive 3. We use the round brackets for this negative 4 and also square brackets for this positive 3. So those are 6 examples of continuous data and set notation, interval notation. That is the main skill from this lesson, although there's the other stuff from up above here. This is the main thing I want you to get away from this. I will say, now that you're at the end of the video, that the set notation is the most important out of the two, as we don't really use interval notation moving forward. And also this green part that I have circled here is the only part that really changes every time. And so this part that I have squared off in the 20 level and the 30 level is honestly all that I really care about for all the different questions. So if you had just the green parts, and this was a 20 level course, 20-1, 20-2, or a 30 level course, 30-1, 30-2, I would accept that for full marks. But in 10C, we do require that whole thing written out, as that is technically the proper notation. So I hope this video helps you better understand domain and range, and yeah, making set and interval notation. Good luck, guys, and have a nice day.